Hi, it's Miss Baker back again with another video. Today I am going to be using MGSE 5 NF4, find the area of a rectangle with fractional side lengths. We're going to look at a concrete method, pictorial, and then abstract. All right, this is what we're working on, 5th grade math. Okay, so the first thing that I want to do is I want to look at 3/4 times 1/3. So what I would do is I would give the kids a scenario. All right. So here is the scenario that I would give, just to kind of get them thinking. All right. Cam has 3/4 of a bag of cookie dough. He wants to send 1/3 of the dough to camp with Chosen. How much will he send? Okay. Cam has 3/4 of a bag of cookie dough. He wants to send 1/3 of the dough to camp with Chosen. How much will he send? Okay. So the first thing that we would do is we would just pretend this is the cookie dough. This is the bag of cookie dough. So what I have to do is I'm going to take this, I'm going to fold it in half, and then I'm going to fold it in half again, because we know that half of a half will give us our fourth. All right, so let's look at this. So I'm going to go ahead and make my lines. Go ahead and make my lines to create my fourths. Now this is my pictorial, right? So it says, if I go back to the scenario, he has 3/4. All right, so that means he has, this is 1/4. Okay, this is 2/4, and this, of course, is 3/4, right? Of the amount that he has, he wants to send 1/3 of it to school. Okay. I also share with the kids a story about horizontal Hannah and vertical Victor. Right now, this is vertical Victor, and then I'm going to use horizontal Hannah to do to make this into my different parts. Okay. So I've satisfied vertical Victor, which is 3/4, and horizontal Hannah mean I have to do it a different way. Okay. So what I'm going to do is now I need to fold this into thirds. And when we do thirds, okay, we normally just make like a burrito fold. Okay. I'm going to just try to make this as even as we can. And we're going to have it to look something like this. All right. So now I folded it into thirds. Okay. So now I am satisfying my horizontal Hannah. Okay. So now what I'm going to do is I'm going to take a different color marker, and I'm going to draw my line like so, like that. All right. So now I need to shade in 1/3, because he has 3/4, but he wants to send only 1/3, which Chosen to camp. So 1/3 will be this. All right. 1/3 will be just one out of the 3 parts. Now, the part that overlaps is going to be your answer. That is going to be the area amount. So this part right here is going to be the area amount. All right. So when you look at it, you're saying, okay, how many parts has 2 colors? You should be able to count 1, 2, 3. All right. So we have 3. Well, how many squares do we have? How many squares do we have together? So we know we had a 4x3, and a 4x3 is going to give us 12. So that means if Cam has 3/4 of a bag of cookie dough and he sends 1/3 to school with, to camp with Chosen, he's going to send 3/12. Now, can we write this in a different way? Absolutely. Is this an acceptable answer for some questions? Yes, it is. But if I wanted to write this in a simpler way, I can do that. So when I go back and I look at my model, I think about all my squares and the amount that I have colored in. Okay. So I have this. How many sets of 3s can I get out of these 12? If I put them in groups of 3, because I know I have 3 out of 12. If I put them in groups of 3, how many groups of 3s can I get out of 12? Well, let's see. This is 1 group. This is 2 groups. This is 3 groups. This is 4 groups. So therefore, this can simplify to be 1/4. 4. Why 1/4? Because I only have 3 out of the 12. That's only the one group that has 2 colors. So 3/12 is the same as 1/4. Okay, that's our pictorial, right? I'm sorry, this is our concrete. Now, for the pictorial method, what you want to do is think about the problem. I am going to write the problem on here so you can see it. So we know we have 3/4 of, or we can say 1/3 of 3/4, 3/4 of 1/3, however, okay, that is fine. So I'm going to draw this out and I'm going to let this be my horizontal Hannah. All right, so that means I'm going to go over 4. 1, 2, 3, 4, and I love dot paper for this. Then this is going to be my vertical Victor. Okay, 1, 2, 3. All right, so I've pretty much made the outline for my area. I have 4 and I have 3. So I'm going to close this in, and this is the amount that I'm working with. This is all. Okay, so now I'm going to go ahead and make my lines. Okay, which pretty much end up being a little bit different. Let me change this. And this is another lesson. It doesn't matter which one is horizontal, which one is vertical, you're still going to get the same product. So we're going to make this one vertical and then this one horizontal. Okay, so I'm going to shade in 3 out of 4. 1/4, 2/4, 3/4. Okay, then for my next one, I'm going to draw my lines, make my partitions, and I'm going to shade in 1/3, and I'm just going to use dots. Why am I using dots? Because I want to be able to see which boxes have 2 different colors. Okay, so I have my 3/4, 1, 2, 3, and I have my 1/3, 1 out of the 3. The part that overlaps, which is right here, represents my answer, which is the same thing that I had right here when I discovered it with my concrete model. So that means I have 3 out of 12. And remember, we said, well, how many sets of 3s can I get out of this model? And we said we can get 3 sets, but we only have 1 of them shaded with 2 colors. So that's the same as 1/4. Okay, 1/4. Right? Now, for the abstract part, which is kids want to jump to this part when they don't understand what the model or what it means. They just know that it's the process. You have 3/4 times 1/3. All right. Now, you can teach the kids this strategy here. It does work. It depends on where they are. This would be the absolute last thing I would teach kids. That means they have mastered the models. They know how to explain their step. They know what the division part looks like. Then you could do this as an added bonus. I can cross out the 2 3s. Okay. That means I'm dividing both of these by 3s. This will be a 1. This will be a 1. Okay. And all you're doing is pretty much rearranging numbers, still get the same thing. So it almost ends up being something like this: 3/3, 3/3 times 1/4. Will that give me the same thing? Yes, it will. We know that this is going to give us 1 whole, and therefore our answer is going to be 1/4. Or you can give them 3/4 times 1/3, which would get us 3/12. And then, of course, if you want them to simplify, they would divide each one of these by 3. And this is still what they would get. But they need to understand what this means instead of it being just a process that you take, right? Once again, this is a video showing you how to find the area of a rectangle with fractional side lengths. We did the concrete model using folding the paper. We did the pictorial where we drew it out. We drew an area model. And then, of course, you could do the abstract. Okay. Hopefully this helps.